Hi and welcome back. So in the past video we kind of started an introduction to ions, and specifically we were looking, and I'm actually going to scroll down because I don't need all of my periodic table. We were looking specifically at sodium, which is right here on the periodic table, and chlorine, which is over here on the periodic table. And one of the things that I certainly thought about when I was first learning about ions was that if we take a look at, you can sort of think of, and I'm not going to draw a real accurate representation of the atom, but if we take a look, if we said, okay, look, sodium, what defines sodium is the fact that inside this nucleus, so we'll say that inside this nucleus, and we're not going to worry about the neutrons, we're just going to worry about the protons, that inside this nucleus, that there are 11 protons. 11 protons. And we know that a proton has got a positive charge. And then, essentially, and we're not going to worry really about the shape of the orbitals for these electrons, we're just going to say somewhere around that nucleus, there are also here 11 electrons. 11 electrons. And they have a negative charge. And then we can say the same thing for chlorine. Chlorine, if we draw the nucleus and then draw all the electrons there around chlorine, that chlorine, and let me actually just label, this was sodium over here. I'll say that this is chlorine over here. That chlorine, inside of this nucleus, there are going to be 17 protons. 17 protons. And then all around chlorine, we're not going to worry about the shape of the orbitals here either, because they're, as hopefully you've realized over the past few videos, there are a bunch of different shapes that the orbitals have. But just around this nucleus, around these 17 protons that all have a positive charge, a +1 charge, that there are also 17 electrons. And they all have a negative charge. And one of the things I know it was sort of, a little bit difficult for me to comprehend a little bit was that somehow, if this sodium atom gave away one of its electrons, and that's essentially what it wants to do. It wants to give, I'll just say that this is an electron, it wants to give an electron to chlorine, and chlorine, chlorine really wants to take that electron. It was almost difficult for me when I was first, learning about that to say, it's like, well, wait a minute. Then that means that sodium is going to have one too many protons and chlorine is going to have one too many electrons. It almost seems like it shouldn't make sense. And essentially what I want to show you in this video is a couple of things about, or to show you essentially what sodium and chlorine are like on their own and what kind of properties they have, and also show you a little bit about what happens when sodium and chlorine form their ions. So sodium, and we'll definitely, in this video I really just want to give you a bit of an intuition or maybe just a little bit of information, I guess, about what sodium and chlorine are like on their own and what they're like together after they react. I don't really want to give you too much of the notation, but essentially what happens is sodium has now, because it's given one electron away, now has a +1 charge, so that's how we write the sodium ion. And the chlorine, because it's taken one electron, and that electron has a -1 charge, chlorine has a negative charge. And this is the notation. I'll go over more of the notation in the future. But essentially, also we don't have to write the 1 in front of the plus sign or the negative side. If the charge is just 1, we can leave the 1 off and just write either a plus or a minus. And don't worry, I'll talk much more about the notation of how we write charges on ions in the future. Essentially, what I want to talk about in this video is that, so sodium on its own. Let's talk about sodium on its own. So sodium is right here on the periodic table. It's an alkali metal. Some of the characteristics of sodium, and actually, you know what, I'm going to scroll over here so we can still see sodium on the periodic table. One of the characteristics of sodium is that if I have sodium, if I'm storing sodium, I'll say, and I'll just draw, we'll say that this is my sodium container. If I'm storing sodium, and let's say that this will be my amount of sodium. I have a little piece of sodium. The only way I can store sodium is if I store it in oil. So I'll make my oil yellow. Because the second that sodium comes into contact with something other than this oil, that's specifically the specific type of oil that it's stored in. So the second sodium comes out of this container, so I'll just draw the sodium out of this container, it immediately wants to start giving away its electron. It immediately wants to start giving away its electron. So that means it immediately starts reacting. It immediately starts reacting with stuff in the air. And it starts corroding. The second you take it out of the oil, it starts giving away that one electron so that it can have an electron configuration like neon. So even though there is definitely an attraction for sodium, like we've been talking, like I kind of said at the beginning of this video, even though there is an attraction or there is a want in sodium, I guess you could say, to remain neutral, to say like, okay, look, I've got 11 protons, I've also got 11 electrons. You know, I'm neutral. I don't have any charge. Shouldn't I be happy with that? And I guess you could say that there is a tendency that sodium maybe does want a very little bit to stay neutral, and you know, maybe really does want a very little bit to not have a charge. But there is a far greater tendency. There is a far greater want in sodium. There is a far greater desire, I guess you could say, if atoms are able to desire something. There is a far greater tendency in sodium to not remain neutral. Sodium really wants to give away that electron. And one of the things that I'm actually going to show you right now is I want to show you sodium. This is a YouTube video I just found, and essentially there are a couple of cool things that we can see in this video about sodium. The first one is that sodium is very soft. One of the characteristics of actually most of the alkali metals that are on, most of the alkali metals, I think it might even be all the alkali metals. I think one of the characteristics of these alkali metals, or at least a characteristic of sodium and potassium and rubidium, is that they are very soft. You can cut them with a butter knife. You don't need to, and you can imagine how hard it might be if you had like a steel rod or something like that. How hard it would be. Could you, do you think you could, you couldn't cut a steel rod with a butter knife. However, sodium and lithium and potassium, you can all cut all of those with a butter knife. So that's the first thing you're going to see. The other thing that you're going to see is essentially what happens. What happens when we drop a piece of sodium into water? When we react a piece of sodium with water, it's going to be a pretty interesting reaction. So I'm actually going to just stop talking. I'm going to play this for you. Turn my sound up a little bit. So he's cutting the sodium with a butter knife. Here it goes. So anyway, you can hopefully see, and I definitely think that any chemistry courses, no chemistry course is complete without something catching fire. But we can see that sodium, it's very reactive. If we put it into water, if we just can cut it with a butter knife and put a little chunk into water, it catches fire when we do that. The other thing, so anyway, that's a little bit about sodium. That is how stable sodium essentially is when it's neutral. So that's what you can essentially think about. When sodium is neutral, it has to be stored under oil because it immediately starts reacting with stuff in the air. And when we put it in water, it catches fire. That's what sodium is like. Those are the characteristics of sodium when it is neutral, when we have the sodium atom. The next characteristic, or the next element that we kind of talked about was chlorine. So we've been talking about chlorine. And I don't have any great videos, but chlorine essentially is very poisonous. Chlorine, it was actually used in World War I as, and hopefully I'm not scaring you too much by telling you this, but it was used in World War I because it was so poisonous. And chlorine, similarly, we said that there has to be some type of tendency because we've got 7 protons and they all have a positive charge, and we've got 17 protons and they all have a positive charge, and we've got 17 electrons and they all have a negative charge. So you can think there must be some type of tendency for these 17 electrons to stay around this nucleus that has 17 protons. And the answer is, well, yeah, there is a little bit of a tendency for that, but the far greater tendency is that chlorine really wants one more electron. It really wants to have, you could say almost an imbalance of electrons. And, you can say that when chlorine is by itself, and we just have chlorine, the chlorine atom, and it's a neutral atom. It has 17 protons and 17 electrons. It is poisonous. So it's essentially, in World War I, it was used as a weapon. It's dangerous. It's dangerous to have around. However, and this is maybe the kicker, and if you're in a chemistry class, I think that this is an example that gets brought up a lot. But when you put sodium and chlorine together and the reaction happens, so if we take sodium and it gives 1 electron to chlorine, so therefore it has a positive charge, and then that chlorine accepts that electron from sodium, what this is table salt. So that's interesting, isn't it? Because this was sodium by itself, we took it out of this container, it immediately starts reacting, we put it in water, and you can think about how much water there might be inside your mouth when, sodium by itself, when you put it in water, catches fire. Chlorine was used in World War I as a weapon, okay? It's very dangerous. It's very poisonous. And I'm not saying this to tell you that you should stop eating table salt. I'm basically telling you this because even though there is maybe a little bit of a tendency for these 2 atoms to stay neutral, and even whatever the tendency is, we're hopefully going to find out in future videos that it can almost boil down to 0, that there almost is no tendency for them to want to stay neutral. But essentially, if they don't stay neutral, if the reaction happens and sodium loses an electron and chlorine gains 1 electron, and this charge happens, we get a compound that is as harmless as table salt. And this video is not meant for you to think that your table salt is dangerous or your table salt is going to blow up if you put water into it. That's absolutely not what I'm saying. And you can even say, humans require salt in order for many different, you need to have some amount of salt in your diet in order to live. But if you have, essentially what I'm trying to show you is that these elements, these atoms, when they're by themselves, when we have sodium by itself, it's essentially not nice. It's essentially not nice. When we have chlorine, by itself, it is similarly not nice. Not a good thing to be around, not safe. But when we have sodium, and it's lost an electron, and chlorine, and it has gained an electron, this is safe. Or nice, we could say. So anyway, that is essentially what I wanted to get across in this video, is that by losing, and this really ties into our, I guess, what we were talking about in terms of what we're going to be doing in chemistry, where we're going to explain, you could say, macroscopic behavior or observable behavior based on microscopic tendencies. This is sort of more or less explaining those types of tendencies. When we have this sodium, and the only difference between these two, this sodium atom and this sodium ion, is one electron. Sodium has just lost one electron, and chlorine has only gained one electron. But it drastically changes the properties of these atoms based on that change. So anyway, I'm actually out of time in this video. In the next bunch of videos, we are going to start talking much more about ions, and I will give you much more specifics on writing ion configurations and everything you would ever really need to know about ions. Essentially, what I wanted to do in this video is just give you a little bit of a sense of that we are able to drastically change the properties of a certain element by doing what might seem like an insignificant little switch, by just having a sodium atom lose one electron and a chlorine atom gain one electron. So anyway, hopefully you found this interesting, and I also wanted to play at least one video in this playlist where we had something catch fire. So anyway, hopefully you found this interesting, and I'll see you in a future video.